Please subscribe, like, and share. It really helps us out. And of course, if you have any questions, comment below and we will answer you as soon as we can. Hey everyone. Welcome back to our IGCSE Chemistry series. Today's topic is acids, bases, and salts, one of the most important areas in chemistry. If you've ever heard of pH, neutralization, or titrations, this is for you. Let's go. An acid is a substance that donates positive hydrogen ions, also known as protons. Examples include hydrochloric acid, sulfuric acid, and nitric acid. A base is a substance that accepts positive hydrogen ions or produces negative OH ions. An alkali is just a base that dissolves in water to release negative OH ions. For example, sodium hydroxide or potassium hydroxide. So remember, all alkalis are bases, but not all bases are alkalis. The pH scale goes from 0 to 14. pH less than 7 means something is acidic. pH of 7 means something is neutral, for example, pure water. pH greater than 7 means something is alkaline. The smaller the number, the stronger the acid. The bigger the number, the stronger the base. Your syllabus includes the following. This means a small change in pH actually means a big change in acidity. This part often confuses students. A strong acid or base fully dissociates in water. A weak acid or base partially dissociates. This is not about how concentrated they are, it's about how much ionizes. For example, a strong acid, an example hydrochloric acid. A weak acid, an example ethanoic acid. A strong base, an example sodium hydroxide. A weak base, an example ammonia in water. When an acid reacts with a base, we call it neutralization. An acid plus a base forms a salt plus water. The hydrogen ions from the acid react with hydroxide ions from the base. And the remaining ions form a salt. For example, the salt formed here is sodium chloride. A salt is an ionic compound formed when the positive hydrogen ion in an acid is replaced by a metal or ammonium ion. Salts can be prepared in different ways. Firstly, an acid plus a base leads to neutralization. Secondly, an acid plus a metal. Thirdly, an acid plus a carbonate. Lastly, precipitation reactions. Different methods are used depending on whether the salt is soluble or insoluble. A titration is used to find the exact concentration of an acid or base. We carefully add one solution from a burette into another in a conical flask, using an indicator to show the endpoint. At the endpoint, neutralization occurs. In calculations, moles of acid equals moles of base, adjusted for the equation ratio. This allows us to find the unknown concentration. Indicators change color at different pH levels. Phenolphthalein, colorless, changes to pink. Methyl orange, red, changes to yellow. A buffer solution resists changes in pH when a small amount of acid or base is added. These are very important in biological and industrial systems. Here are some exam tips. Firstly, memorize the pH scale. Secondly, know strong versus weak qualitatively. Thirdly, learn common indicators and color changes. Fourthly, practice titration calculations. Lastly, be able to name salts. And that's acids, bases and salts explained simply for IGCSE. If this helped, tap like, subscribe, and comment the next topic, maybe organic chemistry or metal reactivity? See you in the next lesson. Thank you for watching our video. Please like, subscribe and share. And comment below so we can clarify things for you.